Okay, hello GED students, this is Mr. Dan, lesson 48, permutations versus combinations. I'm doing the different practice tests. I haven't seen questions come up, or many questions come up on this, so I'm going to show you how to do it in case it does. So first off, the difference between permutations and combinations. When you have a set of numbers, or if you have a set of items where the order of the items matter, well, that would be called a permutation. If the order does not matter, then it's a combination of the items. To show you examples, let's say you have example of a permutation. Let's say you have the letters A, B, and C. Okay, well, how can you order these differently? You got A, B, and C, or you could put B in front, or actually I could keep the A in front and move the C and D, so C and B, so there's a second a way of putting them. Or I could take the B and put that in front, and then have A and C, or I could keep the B in front and have C and A. Or I can move the C to the front and then have A and B, or I could still keep the C in front and switch these two to have B and A. Okay, so you can see there's 1, 2, 3, 4, 5, 6 different ways I could put these in a different order. Okay, so they call that, there's 6 permutations. And this lesson will also show you how to figure out mathematically the number of permutations. Now on the other hand, the combinations, if I have A, B, C, and the order doesn't matter, I could have it as B, A, C, or C, B, A, or it really doesn't matter, I just have C, B, A, well then there's only one combination because the order does not matter. So here, if I have A, B, C, a combination of these 3 letters, there's actually 6 different ways that you can order them, okay, or put them into, order them for the permutation. And actually, I found permutations are actually easier to calculate compared to combinations. Right here it looks easier, but you'll see later on there's an extra step when you're figuring out combinations. Okay, but let's say you do this. We have A, B, C again. Okay, but I only want 2. How many permutations can I make using only 2 letters? Well, here I can match A with B, and then I can switch. Now the order in a permutation, the order matters, so I can switch these, and here's the second one, B and A could be another option. Or I could put the A with C, and then I could switch them, and I can have C and A. So you can see I got 2 more possibilities. Or I can put, let's see, A or B and C together, but then I can switch them, I have C and B. I think, yep, there's 6 ones. 1, 2, 3, 4, 5, 6 possible permutations. Different ways you can order them if the order matters. But if I have A, B, C, and the order does not matter, well, how many combinations can I make? Well, here I can have A and B together, and B and C, doesn't matter the order, so that's 1. Or I can have the A and C together, so A and C. Or I can have, there should be 1 more, oh yeah, B and C together, and they could switch. So here I can actually have, if I have A, B, C, and I was just pairing 2 of them together, well, how many combinations? Well, here it'll equal, there are 3 combinations. If I start out with a set of 3, I just put them in pairs. But how many permutations can you have? Well, if I have 3, and I put them in pairs, and the order does matter, well, then it goes up to 6. Okay, and whoops, I hope Hopefully you saw those before. Okay, so you have 6 permutations when there's only 3 combinations. Okay, and the next video will show you how to do the calculations. And really, it's not that difficult. Permutations are not that difficult. There's just an extra steps that you have to do to figure out combinations. Okay, so to that worksheet that's included, this is the one that I found online. So the first 4 here is just figuring out first, are you trying to figure out the number of permutations or the number of combinations? So here it says I have a team of 8 basketball players. They need to choose a captain and a co-captain. So is this a permutation or a combination? Well, the order matters. I could have, let's say I have 2 kids, Steve and Bill. So Bill's the captain and Steve's the co-captain, or it could go the other way. Bill could be Captain Steve or Bill, so the order does matter. Or it could be Steve and another kid, Frank. So you can have Bill and Frank, or it could be Frank and Bill. So this one here, the order is going to matter. So this one's going to be a permutation. Now, how many permutations can you have? Well, that we'll figure out in the next video. But here, the next one, number 2, is that Bob and Mary, or Rob and Mary, are planning a trip to 9 countries this year. There are 13 countries they will like to visit. They are deciding which countries to skip. So, they got to eliminate 4 of them. Does it matter which 4 or the order of the 4 that they get rid of? No. Okay, the order does not matter. So therefore, if they eliminate 4 from the list, really doesn't matter the order. So therefore, this is going to be a combination, since the order does not matter. Here, the order does matter. Combinations, they do not. Here, the next one, the batting order. The batting order for 7 players on a 12-person team. So I gotta have 7 kids, or 7 of the players in their order out of the 12. And 7 are going to be batting, and the others aren't going to be batting. So how does the order matter? Well, yeah, one person's first, the next person's second, or you can switch them. So here, this one again will be a permutation, because the order does matter. And then number 4, there are 45 applicants for 3 computer programmer positions. So I have 3 openings in the company to be 3 programmers. Doesn't matter which one or the order of the jobs. No, they're all the same job. Okay, I just need to choose 3 out of the 45 people applying. So therefore, out of the 45 applicants, how many combinations? Since the order doesn't matter, it's going to be combination. Okay, so to do these problems, the first thing you got to be able to do is identify if the problem is asking for permutations where the order does matter, or is it a combination where the order doesn't matter. Okay, and then the next video we'll start to show how to calculate the number of permutations you can have out of the set and how many combinations you can have out of the set. Okay, thank you.